Today we're going to start looking at transformations. We're going to spend about 4 days on transformations, and our introduction to transformations is shifting or translations, moving your graph up, down, left, or right, and reflections, so flipping your graph across the x or y axis. So just the top 3 sections of this summary is what we'll be looking at today. We'll look at more later as we get into those. But what you want to kind of take notice of is that anything that is outside the function, so we've got this example of the parent function for absolute value of x. If anything were outside the absolute value bars, that is vertical. Whether you're adding, subtracting, multiplying, or there's a negative sign, if it is outside the absolute values, it's vertical. If it's inside the function, in this case the absolute values, then it's horizontal, and typically it's opposite. So this is where my asylum analogy comes in. The one thing you have to be careful of is when you start to combine transformations, it doesn't always work exactly the opposite. So what you want to do is set what's inside the function equal to 0 to figure out what the shift might be or what the stretch or compression might be as we get to those. If there's a negative, that'll throw off the shift as well. All right, starting with some functions we should be really familiar with, shifting them again. So starting with the critical point, remember the critical point for the parabola is the origin. That's where it changes from decreasing to increasing. So when we shift our graph right 1, up 3, our critical point gets shifted right 1, up 3 as well. The domain for the parent function is all real numbers. That doesn't change when you shift it. The range is based on the y value of the critical point. Because we did not reflect our graph, this one is opening up, so y will be greater than or equal to 3. What I like to do when I graph translations is I think about the t-chart for the parent function, and then I use those points as directions from my critical point instead of doing a t-table and substituting into the new function, because the parent function is much easier to evaluate. So in this case, I am going to be substituting values into x squared. Negative 2 squared is 4, negative 1 squared is 1. You guys know how to square numbers, so I'll fill that in fairly quickly. And then I plot my critical point, so I'm going to use each of these as 2. So I'm going to go right 1, up 3. So there's my new critical point. And then all of those values in my t-chart are directions. So this, instead of being an ordered pair, negative 2, 4, means left 2, up 4 from my critical point. So that's where I'm going to plot my first point. And then I'm going left 1, up 1. 0, 0, of course, is the new critical point. Right 1, up 1. You can also use your line of symmetry. Once you have half the points plotted, or the points off to the left, you can reflect those across the line of symmetry. So obviously that's going to go through the critical point for your parabola. So that's another way to get the other half of your graph. Now we're going to look at the translation of a square root function. I should have done this on the first one. Identified the parent function, that's helpful. Critical point, this one got shifted right 5, because it's opposite, and up 2. So the critical point got shifted the same way. Domain, you want to set what's under the radical greater than or equal to 0. Adding 5 to both sides, we get a domain x is greater than or equal to 5. Notice that is the x value of your critical point. The range you get from the y value of your critical point. Because there were no reflections, it's going to be y is greater than or equal to 2. And we will see reflections later on in this section, and we'll figure out how to find our domain and range when we have reflections. Again, starting with the parent function, and actually I should have fixed this. parent function for the square root, I like to use the perfect squares instead of the -2 to 2, because then you get integers when you're graphing instead of decimals. And of course, you can't substitute a negative into the square root, it's undefined, so we might as well use some defined points for our function. Square root of 0, of course, is 0, square root of 1, square root of 4, square root of 9, square root of 16. Remember, with the function, we're only looking at the positive square root, so we're not going to look at any of those negative values. Plotting my critical point, 5, 2, and I'm going to count each of these by 2 again. And then from my critical point, I'm going to follow these directions. Right 1, up 1. And I'm quickly going to run out of room. Right 4, up 2. And that's all I can fit on my graph. So there is my sketch of the shifted square root.